All right, guys, this is going to be 5.3 kites and trapezoids. So we're going to continue what we know about polygons, but now we're going to specialize or mainly focus on kites and trapezoids. So we're going to identify kites and trapezoids and isosceles trapezoids, and then we're going to use those properties to solve problems, like solve for angles or side lengths. All right, just a quick review. A quadrilateral is going to be a kite. A kite is a quadrilateral with two consecutive pairs of congruent sides. Okay, so two consecutive pairs of congruent sides. So if this one's congruent, then the one right next to it is going to be congruent. Okay, same thing over here. That's one pair. Here's the other pair. So these two are going to be congruent. There's some terminology that I'm going to be using. So the angles that are between the two congruent sides, this one up here, this one down here, those are going to be referred to as the vertex angles. And then the other ones, the one between the non-congruent sides and this one over here between the non-congruent sides, those are your non-vertex angles. So know what that means whenever it's referred to this type of terminology. All right, so investigation one, we're going to discover all the properties of the kite. Okay, so we're going to use a patty paper. I understand if you don't have any patty paper, basically it's just tracing paper. So if you have tracing paper that you can use, perhaps maybe wax paper might work. It might be a little difficult to draw on with your pencil, but if you have some, go grab some right now from your pantry or wherever, or parchment paper, any type of thin tracing paper. If not, you can just try to use a regular paper, okay? But the patty paper is used so that way you can see through it. All right, so what you're going to do is we're going to start off by drawing two non-congruent segments. Okay, so that would be this segment right here that you see, the smaller one, and then here's another one. Okay, and they want to join at a common point, so that's why you see them connected. So draw that right now, okay, on your patty paper if you have it. And then you're going to fold that patty paper along the two endpoints like so. And so when you fold it over, you can see these two lines through the patty paper, okay, or through the tracing paper. You're going to trace those two segments. And then once you trace those two segments and you open it up, it should look something like this, okay? And so since you traced those two segments, that means they're now congruent, right? So this one's congruent to this one, and this side's congruent to this side, okay? So it says name the kite A, B, C, D, okay? And A and C need to be the vertex angles. So this is going to be A, this is going to be C, because those are the vertex angles. They're between the two congruent sides. And so let's just put B over here and D over here, A, B, C, D. And it says, what do you notice about the non-vertex angles? Okay, so this angle right here, let me get a different color, let's say green. What do you notice about that angle and that angle? Well, if you traced it, okay, don't you know that they would be congruent? Okay, and that is true. So this non-vertex angle and that non-vertex angle are going to be congruent, okay? And so, plus if a kite is always drawn to scale, it looks like they are, okay? So that's just a property you're going to have to know from here on out. The non-vertex angles of a kite are congruent. Okay, so we're going to continue to use that kite and discover more because there's a bunch of unique things about the kite. So as we go to the next part, it says use a ruler to draw the diagonals of the kite. All right, so get your straight edge and connect A to C and connect B to D. And make sure they're right at each vertex perfectly. Okay, so you should have both diagonals drawn. And it says name the intersection point E. Let's do that. Go ahead and write that intersection point to be E. And it says measure the angles at E with your protractor. What does that tell you about the diagonals? Okay, so if you have a protractor, you can take that out pretty quickly. But I bet most of y'all can probably imagine what the measure of those angles are. So make sure you line up your protractor perfectly. I'm going to turn it to make sure it's nice and even. Look at that, it's right on the 90. Okay, so let's put a box right there stating that that is 90 degrees. If you just name one, you should know that all four are going to be equal. Okay, so they're all 90 degrees. Therefore, in the blank, the diagonals of the kite are perpendicular. So that's using the word that defines when two lines or segments cross, they form 90-degree angles. So two diagonals are always going to be perpendicular. Again, whenever it's drawn to scale, it is pretty easy to see that they are. Okay, let's go to the next investigation. It says measure the lengths ED and BE. What does that tell you about diagonal AC? So if we were to measure those lengths, okay, so if I were to get my compass and measure those, or if you were to just get your ruler and measure in centimeters, you could do that too. But I'm going to get my compass and get the width of that, and then I'm going to swing it over to the other side and see if it matches up. And technology doesn't allow me to do that. So let me try it one more time. Let me just swing it over that way. Yes, look at that. Okay, just swinging it over left and right. They are identical. So let's get our pencil and let's mark that this side is congruent to this side. So what does that say? This big diagonal, okay, this diagonal that connects the vertex angles, since it makes these two pieces congruent, we're going to use the word bisect, okay? So not only is it the bisector of it, but it also is a perpendicular bisector because it also forms that 90-degree angle like we just talked about a second ago. So I'm going to just redraw that. You're doing all of this on the same kite that you're using, okay? So then that piece is congruent to that one. So make sure you're marking all of these marks on your kite, okay? And let's go to the next one. It says now measure angle DAE, so D to A to the E. So we're going to measure this angle, and we're going to measure EAB, E to the A to the B. We're going to measure this angle. And it says also measure, let me get a different color, angle DCE, so this one down here, and measure BCE, B to the C to the E, this one right here. Well, if you had to guess just by looking at it, what would you say is true about each angle? It looks like this one is congruent to this one, okay? Again, you can get your protractor out and measure it if you'd like. I'm going to turn this around and line this up. Right there, it looks like this is about 46 degrees. And that looks like about 92. So 92, 46 and 46 make 92. So yes, those two red ones are congruent. Same thing goes down here. If I line up my protractor right here, looks like about each one is about 25 degrees or so, pretty close. I don't have it actually lined up perfectly. There we go. Looks like it's right at the 25, and then yeah, now that's right at the 50 once you line up the protractor correctly. So that side is also congruent. This angle, that side is congruent to that angle. Let's use 2 marks. Okay, so what does that tell you about the diagonal? Well, these angles down here, A, big angle A and big angle C, those are our vertex angles. So that's how we're going to start it off. The vertex angles of a kite are bisected by the diagonal. So this diagonal is going to bisect it. So this whole entire left side of the kite is symmetrical to this whole side over here. Okay. All right. And that is it for all of the properties of a kite. So make sure you have all of that down. So your final product should look probably something like this, because I didn't keep repeating it, but we had this piece was congruent to this one. We had this whole entire angle was congruent to that whole entire angle. We had the 90-degree angle at the center. We had the bisector. Of course, you should know that this piece is congruent to that one, and this one's congruent to that one, which means we should probably use 3 here. All right. And those are all of the properties, okay? So good thing is when it's drawn to scale, it's pretty easy to see that. All right, let's go to the next quadrilateral that we're going to talk about. This is a review. We're going to talk about the trapezoid now. The trapezoid is a quadrilateral with one pair of parallel sides, okay? So you should either see these little symbols right here, or you should just have the statement that it is a trapezoid, and so therefore you have to know that those are parallel. What we call the parallel sides are the bases. So this top one and this bottom one are the bases. So therefore, this is going to be a pair of base angles, and these two down here are going to be a pair of base angles. And so they kind of stick together, all right? So if you hear us talk about that, or it's on your homework, when it refers to the base angles, know that this is one pair and next to each base. And then the other pair is on the other base. Okay, so let's discover some properties here. Okay, it says use a ruler to create a set of one parallel sides to create a trapezoid. Now, this is kind of the cheating way, okay? And so just because we're doing the notes, we want to kind of get through it a little bit quicker, okay? So we're going to create a set of parallel sides like this, one here and one here. And it says, make sure and draw the non-parallel sides to be non-congruent. So I'm going to extend it out a little bit more. All right, so that's what it means by using the ruler. So I'm going to go ahead and connect there to there. And then I'm going to connect the other one over here. You'll notice it's longer because it says to make sure that they're not congruent. So I'm going to connect from there to there. And that's really all we need with the ruler. Okay, now the way you really construct parallel lines, and you're going to have to do it on your homework, is remember you have to make a longer transversal, and you have to copy this angle up here, corresponding angles. All right, so it says label the trapezoid QRST, and it says with QR and ST to be the bases. So QR and ST to be the basis. So we're going to say QR is here and ST, like so. So those are the bases. And it says, how is Q related to T? How is Q related to T? So that means this angle here, how is angle 1 similar to angle 2, and or how are they related? They're obviously not congruent, okay? I don't know why I said that. They are, one's obtuse and one's acute. Well, you should know that these are known as the same side interior angles from previous knowledge, okay? It also asks, how is angle R related to S? So let's call that angle 3 and angle 4. So how is 3 related to 4? Those are also a pair of same side interior angles. If you were to take out your protractor and measure both of those, what do you think those both would come out to be? Okay, well, that one and that one would probably equal 180 degrees because that's what we already learned. Same thing goes for this one. That one and that one, those would equal 180 degrees. So what happens when two angles equal 180 degrees? That means that the consecutive angles between the bases are supplementary. Okay, so that's something that you technically already knew, because that's when we talked about this way back when we talked about parallel lines cut by a transversal. You learned that the same side interior angles are supplementary. Same thing goes for this one. This is the same side interior. Those are supplementary. Okay, so remember that property. Okay, On this one, it says use a ruler to create one set of parallel sides to create a trapezoid. So we're going to do that again, except this time it says the non-parallel sides, those now need to be congruent, okay? So we're going to have to use our ruler to use that, or we can use our compass. I like using the compass, so I'll probably use the compass to make sure they are congruent. So I'm going to come over here. I'm going to make a longer bottom piece, and then I'm going to connect from here to here. Let's make sure it's right on each endpoint, like so. All right, so I want this side right here to be congruent over here. So I like using my compass, so I'm going to use that. If you want to use centimeters on your ruler, you can measure it in centimeters and make sure the other piece is equal to that. But I'm going to just get the exact measure like this. I'm going to come over here to this top end, because this is the shorter side. Make sure it's right on the end point, and then kind of just swing your compass and make an arc like that. Okay, so I measured it exactly. Again, if you want to measure it in centimeters, you can measure it in centimeters and make sure it comes out the same size. So line it up perfectly at each endpoint and make sure it goes right through that intersection point. All right, so I just made this congruent. So I'm going to put a tick mark here and a tick mark here. And this is what you call an isosceles trapezoid, okay? So whenever you have a trapezoid and the non-congruent sides are congruent, this is an isosceles trapezoid. So very similar to the isosceles triangle because two sides are congruent. All right, so it says label this trapezoid QRST again. Let QR and ST be the basis. So let's do that. Q, R, S, and T. And it says, how are both pairs of base angles related? So basically, let's compare angle 1 to angle 2, and let's compare angle 3 to angle 4. What would you say about angle 1 and angle 2? They look pretty closely related to me. And they're congruent, just like they would be in a triangle. Remember the base angles in an isosceles triangle are congruent? Well, remember, if you were to continue these two sides up, that would create an isosceles triangle. So the base angles of an isosceles triangle are congruent. So let's go ahead and mark those right here. So this one would be congruent to this one, and this one here would be congruent to this one here. Okay, and again, the good thing is when they are drawn to scale, it's real obvious that they are congruent. You just now need to use those and apply them to problems. All right, let's go to the next property. So on that same trapezoid that you just constructed, it says use a ruler to draw both diagonals. Okay, so get your ruler and draw a diagonal from Q to S and T to R. So draw both of those diagonals. And it says label the intersection point V. So let's label that intersection point V. So then it says compare segment QV to RV. So that's this one here to this one here. What would you say about those two? They look pretty closely identical. If you wanted to make sure and show proof, remember you can always use your compass, and you should still have this. Okay, in fact, you're going to need it for your homework. Okay, so you're going to place it here. Let me turn it the other way. So I'm going to place it at V, and I'm going to get the exact measure to Q, something like that, and then I'm going to swing it around this way. Look at that, it's exactly the same. Okay, so then it says compare TV to VS. That one's going to be the same as that one as well. Okay, again, you can check with your compass just to be sure. Measure from there all the way to T, and then swing it around this way. Looks like it's going to go right through it, and I messed up my. There we go, right on the money. right there. So they are congruent. So what does that tell you about the two diagonals? Well, the whole entire diagonal TR would be congruent to the whole entire diagonal QS. Okay, always and forever in an isosceles trapezoid. So congruent is what goes in that blank. Okay, so all these properties are pretty easy. Now you just got to apply them to problems and maybe solve for side lengths and angle measures. Okay, so let's just do one last construction problem because this will be on your homework, okay, and will possibly be on your test. So it says construct kite ABCD and use the given sides, AB, and then we have CD. All right, so the first thing that you want to do is kind of imagine how a kite goes. I used to say this back when we did our construction unit. Sketch it off to the side. So here's going to be my kite. One is shorter, one is longer. You know that a kite, those need to be congruent. So let's remind ourselves about that. So this one could be AB. That's the shorter segment. Obviously, C will go here and D here. So now you have an idea of what it's going to look like, okay? So now we're going to just actually construct it. So I'm going to get my ruler and I'm going to start off by drawing a segment. So I'm going to draw a segment and make it a little bit longer than AB because you're going to actually go measure how big AB is. Remember how we used to grade constructions. I know we haven't done constructions in a while, so that's why I want to put one of these on the notes. So we're going to place it at this end point. Okay, let me get a different color. And I'm going to make an arc here. So that's going to be side AB. So let's go ahead and mark that. This is A, and this is going to be B. Okay, now you know BC is going to be the same length as CD. So what we can do is we can construct a longer segment over here from B like this. Now, did it say what this angle needed to be? No, so we actually can make it whatever angle we want. So I'm just going to go, I don't know, something like that. So I'm going to make a long segment. And now I'm going to get my compass and get the actual width of how big this side is supposed to be. So there we go. Now I'm going to place it at B right here. And I'm going to there we go. Now I'm going to make an arc down here. All right, so that's going to be my point C, everybody. So I'm going to put a little C down there. Okay, so now I just need the other two sides. Well, you know that they have to be congruent to each other. Well, since I already have this length on my compass, I know that side CD is going to start from C. So I'm going to come here. I'm going to place it on point C. Let me bring my compass up. Hold on, give me 1 second while I work with technology. And it's not letting me, so I'm just going to come over here and I'm going to make an arc somewhere over here. I don't know where it's going to be, so I'm just going to make it kind of large. And then I'm going to, there we go. So now I'm going to come over here. I know that the other segment has to be the length of this segment. So I'm going to place it at A. I can't place it on the green arc because I don't know where to place it at. I'm going to place it at A, and then I'm going to make an arc like so. So guess what that intersection point is going to be? A, B, C, that's going to be our point D. So now we just have to get our ruler and connect these two. And the last segment. Always make sure it's right at the intersection point. So you have to make adjustments if needed. There we go. So that is a perfectly constructed kite with those given measures that they gave us. So you're going to have a similar problem to this on your homework, okay? And you might see one on the test at the end of this unit. All right, so how many arcs do you see? We needed 1, 2, 3, 4, at least 4. Are there other ways to do it? Possibly so, okay? That's always the situation with math. You can construct it lots of different ways, and you can always solve math problems lots of different ways. But this is one way to do that. And that is it.